Failure will never overtake you if your determination to succeed is strong enough. Hi everyone. In this video we'll go through additional problems from exercise 1.2 related to types of functions. Also, you can refer relations and functions playlist for all other videos. You can also join the Telegram group Bina 2A classes for mathematics. Let's look at the 8th problem. Let A and B be sets. Show that function from A cross B to B cross A is defined by f of AB is equal to B comma A is bijective. We'll have to show that it is bijective, means we'll have to prove that it is 1-to-1 and onto. Now A cross B is a Cartesian product, right? So we'll take an example. Let's take set A with elements 1, 2, 3, set B with elements 4, 5. Randomly we are picking two sets here. Now what is A cross B? What is the Cartesian product of A cross B? It will be 1 with 4, 2 with 4, 3 with 4. 1 with 4, 2 with 4, 3 with 4. Then again with 5 we will do. 1 with 5, 2 with 5 and 3 with 5. So this is A cross B. Now similarly, what is B cross A? You will take 4 with 1, 4 with 2, 4 with 3. Then you will take 5 with 1, 5 with 2 and 5 with 3. Right? This is B cross A. Now we'll write it in this particular notation, A cross B and B cross A. So take all the ordered pairs here and put it here. 1, 4, 2, 4, 3, 4, 1, 5, 2, 5, 3, 5. And we'll take all the ordered pairs in B cross A. All this, right? Now, the function, how is the function given? If you have function of A comma B, then the reverse, B comma A. So if you have 1, 4, then it is mapped to reverse. What is reverse? 4, 1. Here. If I take 2, 4, then it's mapped to reverse, 4, 2. That's what it means. Function of A comma B is nothing but B comma A. So reverse it. So I have 3, 4, so it will become 4, 3. 1, 5, so 5, 1. 2, 5, so 5, 2. 3, 5, so 5, 3. So everything is mapped here. Now, by looking at this, you can say it's 1, 1. Because every element in this particular set is having a different image, distinct image. Therefore, this is 1-to-1. You can say every element in A cross B has distinct image in B cross A. Therefore, function is 1-to-1. Now, using the general method also, you can say we can say that it is 1-to-1. F of x1, we start like this. F of x1 is equal to f of x2. Now, instead of x1, we have two elements A comma B. So, f of A1 comma B1 should be f of, instead of x2, you have two elements. What is that? A2 and B2. Right? So, we'll say A2 comma B2. Now, what is function of A1 comma B1? What is function of A comma B? It's B comma A. Right? So, I will write this as B1 A1. And this will be B2 A2. Now, if both of these have to be equal, that means individually it should be equal. This means that B1 is equal to B2 and A1 is equal to A2. Only then these both will be equal. If B1 is equal to B2 and A1 is equal to A2, only then these can be equal, right? So this is like proving that when f of x1 is equal to f of x2, it implies that x1 is equal to x2. That's what we have proven here. B1 is equal to B2 and A1 is equal to A2. Or you can write it as B1 comma A1 is equal to B2 comma A2. B1 comma A1 is equal to B2 comma A2. Therefore, function is 1, 1. Now, let's look at onto function. By looking at this itself, we can say it's onto because every element here is mapped to some element here. Therefore, it's onto. So, you can say every element in B cross A has a pre-image in A cross B. Therefore, f is onto. Therefore, function is onto. So, if you have to write generically using the onto method, we'll say f of A comma B is B comma A. Right? This is the function. And B comma A belongs to B cross A and A comma B belongs to A cross B. Therefore, f is onto. You can use this method and also say it's onto because B comma A belongs to this Cartesian product and a comma b belongs to this particular Cartesian product. Therefore, f is onto. It's like this. Here, this is a comma b and this is b comma a, right? A comma b belongs to this set. B comma a belongs to this set. You can take any set and figure out that a comma b belongs to this set and b comma a belongs to this set, and therefore it is onto. Now let's go to the next problem. Let function from natural number to natural number be defined by f of x is equal to n plus 1 by 2 if n is odd and n by 2 if n is even, right? Now state whether this function is bijective, right? That means you have to show that it is onto, it should be onto and 1, 1. Now what does this function mean? Let's check 1 to 1 first, right? You can assume that there are two sets like this, right? Both are natural numbers, right? Function from n to n. So you can take the natural numbers as 1, 2, 3. Natural numbers are only positive numbers, right? So on. And here also you have 1, 2, 3 and so on. Now we'll take 1 to 1 case. Let's take n is equal to 1. We'll take this number. Then what is f of n? F of n is, what is 1? 1 is odd. If it is odd, it should be n plus 1 by 2. This is n plus 1 by 2. So 1 plus 1 by 2, which is 2 by 2, which is 1. So this will be mapped to 1. Now let's take n is equal to 2. N is 2. It's an even number. If n is even, you will take n by 2. So function of n is n by 2. It is 2 by 2. It's going to be 1. So if I take n as 2, f of n is going to be 1. Here itself it becomes many to 1. Many to 1. Because both 1 and 2 are mapped to same image. Therefore this is many to 1 and not 1 to 1. So you can say f of 1, this one, is equal to f of 2, this one, and both have same image, which is 1. Therefore f is not 1 to 1. Now let's check if it is onto. Now for onto, every element in this set should have pre-image. Only then we can say it's onto. Now you can just take few examples, say 1 to 4 here, and figure out. 1 anyway, we know there are pre-images here. Let me use n is equal to 3, right? If n is equal to 3, then f of n will be 3 is odd number. 3 is odd number, so I'll have to use this function n plus 1 by 2. It is n plus 1 by 2, which is 3 plus 1 by 2, 4 by 2, which is 2. So if it is 3, I get f of n as 2. I can take another one, n is equal to 4. This is even number, right? For even number, the function is n by 2. N by 2. So 4 by 2, which is 2. So if n is 4, f of n is 2. If n is 4, f of n is 2. So like this, you will see that every element here will have a pre-image. Therefore it becomes onto. Now we'll use the generic onto method and figure out, right? We can do that way also. When n is odd, f of n is n plus 1 by 2. When n is odd, right? So we'll take this particular case first. So f of x is equal to n plus 1 by 2, right? We'll take it as f of n. F of n is equal to n plus 1 by 2. So let y is equal to f of n. So this is nothing but n plus 1 by 2. So I'll shift this here and just find the value of x, value of n, right? We normally have f of x, right? This is how we'll get normally. Now instead of x, we have n here, that's it. So we'll shift this 2 here. So we'll get 2y is equal to n plus 1, or rather n is equal to 2y minus 1. Now I'll find this f of n here. So what is f of n? N plus 1 by 2, right? But instead of n, what should I put? This 2y minus 1. So instead of n, I'll put this 2y minus 1. So it will be 2y minus 1 plus 1 by 2. Minus 1 and plus 1 will get cancelled. So I'll get f of n is equal to 2y by 2. 2 and 2 will get cancelled. I'll be left with y. And f of n is equal to y. And this y would belong to natural numbers. Therefore, function is onto. We'll say function is not bijective because we'll have to justify the answer, right? They have told that we have to justify the answer. We'll say function is not bijective because it is onto but not one-to-one. Now let's go to this example. Let set A be a set of real numbers, but it does not include 3. It's all real numbers without 3. And set B is all real numbers without 1. Now consider the function from A to B. It's defined as x minus 2 by x minus 3. You will have to tell if this function is one-to-one and onto. Justify your answer, right? So first we'll figure out if it is one-to-one and then onto. So we'll use this method. F of x1 is equal to f of x2. So this will be x1 minus 2, right? F of x is x minus 2 by x minus 3. Instead of x, I'm putting x1 here. And here, instead of x, I'm putting x2. Now what will happen? I'll cross multiply, right? I'll cross multiply this. So I'll get x1, x2. I'll get this entire expression, right? You'll see that a few terms get cancelled. And you'll be left with these terms. You get all x1 terms on one side and all x2 terms on the other side. All x1 terms are here. All x2 terms are here, right? So what will happen? You'll get 3x1 minus 2x1 is x1 and 3x2 minus 2x2 is x2. So x1 is equal to x2. Therefore, function is one-to-one. Now, we'll try the onto case also. We'll check if it's onto. So function is x minus 2 by x minus 3. Let y is equal to f of x. Therefore, y is equal to x minus 2 by x minus 3. Now, we'll cross multiply here, right? So we have to cross multiply and just get the value of x. So it will be x into y minus x into y minus 3y is equal to x minus 2. So what I'll do, I'll bring x terms together. So xy minus x minus 3y, I'll bring minus 2 this side, so it'll become plus 2 is equal to 0. Now I'll club the x terms here. So it will be x, I'll take common factor. So I'll be left with y minus 1 and minus 3y plus 2, right? So I can write this as, I'll take this entire thing on the other side. So I'll get 3y minus 2 equal to this one, x into y minus 1. Now I just need to find the value of x. So x will be 3y minus 2 by y minus 1. Now I'll apply function on this. What will f of x be? F of x is x minus 2 by x minus 3. Now instead of x, I'll put this entire thing instead of x. So I'll get 3y minus 2 by y minus 1, the whole minus 2 by 3y minus 2 by y minus 1, the whole minus 3. So this will be f of x is equal to, I'll cross multiply here. So it will be 3y minus 2 into y is minus 2y, minus 2 into minus 1 is plus 2 by this particular denominator, which is y minus 1. The whole divided by, now I'll cross multiply this. So 3y minus 2, minus 3 into y is minus 3y, minus 3 into minus 1 is plus 3 by denominator, which is y minus 1. Here plus 2 and minus 2 will get cancelled. Here 3y and 3y will get cancelled. 3y minus 2y is y. 2 and 2 is cancelled by y minus 1. Here 3y and 3y is cancelled. Minus 2 plus 3 is plus 1 by y minus 1. Now this y minus 1 and this y minus 1 will get cancelled. So I'll be left with y by 1, which is y. Now we got this. F of x is equal to y. Therefore, function is onto. So we proved that function is 1, 1, and we also proved that function is onto. So we'll say since f is 1 to 1 and on to f is bijective. Now let's go to the next problem. Let function from real number to real number be defined as x to the power 4. Choose the correct answer. Now anytime you have a square function or a function to the power 4, function to the power 6, function to the power 8, anything to the power, right, even power. So what will happen is both positive x and negative x will have the same image. So it will be many to one. Anytime the functions have even powers, right, it will never be 1 to 1. It will always be many to one. So you can take examples and check. So if I take x is equal to 2, then 2 to the power 4, right? This is x to the power 4. 2 to the power 4 would be 16. If I take x is equal to minus 2, then also minus 2 to the power 4 will be positive itself, right? So whether I take positive x or negative x, my image is going to be same, right? It's going to be same. Therefore, this is not 1 to 1. Now, would it be onto? Anytime you have square function or functions with even powers, it will not be onto, because now this is real number to real number, right? Negative numbers will never have pre-image. Take this example. This is real numbers. This is also real numbers. So you could have negative numbers also here, right? So 1 to the power 4 is 1. 2 to the power 4 is 16, right? Similarly, minus 2 to the power 4 is also 16. So here you see 16 has two pre-images. One is minus 2 and plus 2. So therefore it is not 1 to 1. Similarly, it's not onto because this number 2, 3, 4, 5, they don't have a pre-image. The image for 1 is 1. For 2 it is 16. Between numbers 1 to 16, there is these numbers 2, 3, 4 till 16, they have no pre-images. Therefore it's not onto. So the right answer is D. F is neither 1, 1 nor onto. Let's look at this last problem. Real number to real number. The function is defined as 3 times x, 3x. Choose the correct answer. 3 times x. It's real number to real number. Right? You can use this method. Right? So 3x1 is equal to 3x2. 3 and 3 will get cancelled. So left with x1 is equal to x2. And both of these belong to R. Therefore it's 1, 1. Now we'll check if it's onto. F of x is equal to 3x. So y is equal to 3x. Therefore x is equal to y by 3. X is equal to y by 3. Now you apply function on this. F of x is 3x. Instead of x, I'm putting this one, y by 3. 3 and 3 will get cancelled. So f of x is y. Therefore it's onto. So this function is both 1, 1 and onto. The right choice is first one. F is both 1, 1 and onto. So with this, we've come to the end of this particular topic. If you have liked this video, do press a like and share it. Thank you.